Value natin ng critical, 2.819, positive and negative. So, assuming this is the positive 2.819 and the negative 2.819. Okay. Ano naman yung na-compute natin? Sabi natin, we have 3.953. And nasaan si 3.953? On the positive side. More likely, nandito yan. That is 3.953. And since sabi natin, this is a rejection region, and that is the region where our T computed actually falls, no? Nandoon siya sa loob nun. Therefore, our decision should be to reject the null hypothesis. So, reject ang null hypothesis. Since we reject our null hypothesis, let's go back to our hypothesis. Na-reject ito, therefore, tama ito. And yes, hello everyone. Welcome to our next presentation. So for this presentation, we will going to have our topic regarding the hypothesis testing two population, testing the difference between two means. Lastly, last time we've talked all about large independent sample. So this time, we will going to talk all about the small independent samples. Okay? So let's start our discussion. Again, testing the difference between two means, small independent samples. Okay. Now, when we say t-test for independent samples, or some books, some statisticians call this as student's t-test, this is actually used to test the significance of the difference between two sample means. Kung meron ba silang pinagkaiba or wala. So this can be used to compare the sample means between two independent samples. Again, independent samples. So when you say independent samples, basic of mathematics, independent samples are two different samples that doesn't care with each other. Kasi pag dependent sample, yung isang variable, nakadepende dun sa isa. Kapag independent, they doesn't care with each other. Titignan natin dito, meron ba silang significant difference or wala? Yung independent samples na yun. Okay. A parametric test which assumes a normal distribution. Take note, guys, for the assumptions, normal distribution meron tayo. And it is used for smaller samples. When we say smaller samples, this is samples with 30 or less na data. Yung last time, we have there the large independent samples, and we're dealing there sa data natin is 30 and up. Okay? So, greater than or equals to 30 ang n. Now, with regards to the name itself, T-distribution was actually developed by G.W. Gossett in 1908 and published the pseudonym student. Kaya, kinalaunan, yung T-distribution, tinawag na siya student's T-distribution because of the pseudonym student by Gossett. Now, with regards to this topic, the assumptions are, first assumption, subjects are randomly selected and independently assigned to groups. Take note na independent yung assignment for the different groups of population, for the dependent population. And those population variances are homogeneous, meaning of the same, on the same level, on the same type of data, something like that. Number 3, population distribution is normal, just like what the PowerPoint presentation on the previous slide is saying. Normal distribution ang isa sa assumptions natin dito. And for the example, so let's have this example. So, testing the difference between two means, small independent samples. A researcher wishes to determine whether the monthly salary of professional and elementary teachers in private schools and public schools differs. Titingnan niya, Tagalogin natin, titingnan niya kung meron daw bang pagkakaiba, different ba yung salary ng mga elementary school teachers between the public schools and the private schools. So, he selects a sample of elementary teachers, and from each type of school, calculate the means and standard deviation of their salaries. Again, from each type of school, calculate the means and standard deviation of their salaries. at alpha level 0.01, can he conclude that the private school teachers does not receive the same salary with the public school teachers? Ayun yung claim. Kung titingnan nyo, ang claim kasi, ang tanong niya, can he conclude, pwede daw ba siyang mag-conclude na yung salary ng private school teachers is hindi pareho doon sa nare-receive na salary for the public school teachers? So, meaning to say, that will be our claim. And since we use there the does not receive the same salary, so does not equal, we use not equal there, basically, our claim will be the null, the alternative hypothesis, the H sub 1. Okay? Now, assume that the populations are approximately normally distributed. We have here the tabulation of the given. I will just have my pen. Let's use color black now. Okay? So, we have two sets of population. That's why ang topic natin is two independent samples, no? Two means of a small independent samples. By small, again, because our sample size is less than 30. As you can see, we have here 15 and 9. Okay, so for the private school teachers, this will be the group 1. For the public school teachers, this will be our group number 2. Okay, for the data, we have the mean. So, what we will going to use? Mu or X bar? Basically, what we will going to use is X bar, not mu. Because mu is for population mean. And since, based on our problem, we only selects, the searcher only selects a sample of elementary teachers. So, we will going to have only a sample mean. And of course, since we use the sample mean, our standard deviation should be sample 2. So, this is letter S, not sigma. And of course, for the sample size, letter N. Okay, so meaning to say, since this is X bar and this is 1, this will be the X bar sub 1. This will be the X bar sub 2. Okay, since this is the second population, the second data set. Now, this will be S sub 1 or the sample standard deviation of the first population, which are the private school teachers. And this will be now the S sub 2, which is the sample standard deviation of those public school teachers. Okay, so N sub 1 or the sample size of the population 1 and N sub 2 or the sample size of the second population. So basically, that is our given. Let's have our solution. For the first part of our solution, just like on our previous topic, we used to have here the H sub 0 for the null hypothesis, and for the alternative, we have H sub 1. Okay, again, based on our last part of the problem, can he conclude that the private school teachers does not receive the same salary with the public school teachers, does not receive the same salary with the public school teachers? Meaning to say, our alternative hypothesis will be the claim, which is the mu1 or the population 1. Take note, guys, no, we used here X bar for the mean, but now we're trying to have mu. Sir, mu is actually this is actually population mean, 'di ba, sir? Yes, tama kayo. That's why we are having a hypothesis dito. Doon natin siya ginamit, yung mu sa hypothesis na, no, sa hypothesis formulation, and not doon sa given. Dahil yung given natin is just the sample. Again, with inferential statistics, we are trying to make an inference coming from our sample. Okay, that's why we use na dito is for population na mu. So, mu sub 1 or the population of our private school teachers, that is the first group, and the second group is the public school teachers. Mu sub 1 is not equals to mu sub 2. This will be our claim based doon sa last part ng ating problem. I hope you get it. Now, next, let's have the null hypothesis, which is mu sub 1, since we used here not equals, therefore sa null hypothesis equal yan. No, hindi ka pwede maglagay ng greater than equal or less than or equal, since naka not equal ka for H sub 1. Next, mu sub 1 equals to mu sub 2. And that is not the claim. Okay, so mu sub 1 is equals to mu sub 2, which is our null hypothesis. This means that there is no significant difference dahil equal na 0. This means, again, there is no significant difference between the monthly salaries of the private and public school teachers, elementary teachers. For the h sub 1, mu sub 1 is not equals to mu sub 2, which is our claim. This basically means that there is a significant difference. There is a significant difference. May pinagkaiba, kaya hindi sila equal. Wag malilito doon. There is a significant difference between the monthly salaries of private school teachers and the public school teachers, elementary school teachers. Okay, I hope you get it. That is how we formulate our hypothesis. For the level of significance, based on our problem, our level of significance is 0.01. So, let's write here. Alpha level, 0.01. Okay, so 0.01 alpha level. And of course, we will be having here a degrees of freedom. No, why meron tayong degrees of freedom, sir? Di ba, ano tayo? Lower than 30? As I have said before, once na lower than 30 ka, you will be now having your degrees of freedom. And since we are talking here about two means coming from small independent samples, what our formula for the degrees of freedom will be now n sub 1 plus n sub 2 minus 2. I-add natin sila gaano karami yung sample for first group of dataset or for the first population, gaano karami yung sample for the second population, minus 2. Where does this number 2 came from? This actually came from the number of samples na meron tayo or the number of groups of samples. Okay, we have two, the public and the private school teachers. Okay, so n sub 1 is 15, n sub 2 is 9. So, meaning to say, we have here 15 plus 9 minus 2. So, 15 plus 9 is, minus 2 is 22. Okay, so 22 ang ating magiging degrees of freedom. Now, for the critical value, let's have our table. So here we have our table, and based on our degrees of freedom, we have here 22, and of course, we have the alpha level 0.01. Now, take note guys, before we proceed on the table, since we used here an equal and unequal, now equal and not equal, meaning to say this is a two-tailed test. Okay, why two-tailed test? Dahil walang binibigay na direction, either going to the right or going to the left. So again, this is a two-tailed test. Two-tailed test, 0.01, 22 degrees of freedom. So let's check it on our table. So here we have our table. Two-tailed test, 0.01. So here we have here, and 22 degrees of freedom. 22. Here, we have 2.819. So, 2.819. This will be our critical value. Okay? 2.819. Critical value. And since this is a two-tailed test, there must be plus and minus sign. No, plus, minus, or positive, negative sign. Meaning to say, we have two critical values here, positive 2.819 and the negative 2.819. Visually speaking, this will be at the end of both sides or the both tails of our normal distribution curve. Okay? So, next, we can now have our solution for the t-test value. So, here on the t-test value, we will going to have the formula for the variances that is assumed to be equal, because actually there's a separate formula for the variances that is assumed to be unequal. Okay, so again, we will use here the formula for the variances that is assumed to be equal based on our assumptions on our previous slide on the first part of this presentation. So what's that formula actually looks like? Madali lang naman siya. That is basically T equals x bar sub 1 minus x bar sub 2 minus the difference of the two population, mu sub 1 minus mu sub 2. All over, as you can see, almost the same with the formula on our previous topic, but there is a difference on the denominator. All over square root. So let's have here square root of n sub 1 minus 1 multiplied to s sub 1 squared, or the first sample standard deviation squared, plus we have here n sub 2 minus, this is 1 guys, okay, minus 1 multiplied to s sub 2 squared, or the sample standard deviation of the second population, all over the n sub 1 plus n sub 2 minus 2, or basically all over the degrees of freedom, because they're just the same formula as you can see here. N sub 1 plus n sub 2 minus 2. This is multiplied to the square root of, we're not done. There's still another part of the formula. 1 over n sub 1 plus we have 1 over n sub 2. So, ayan ang ating formula. Okay? So, let's start our computations for the value of the t test. Okay, so x sub 1 bar or n minus x sub bar 2. What are those numbers? That is actually based from the given. Ito po sila. So, 16,400. Let's write it here. 16,400 minus our x bar sub 2. What is that x bar sub 2? Ito po. 15,170. 15,170 minus mu sub 1 minus mu sub 2. Again, based on our given, there's no such thing as mu here. Kasi nga, yung mu natin is the population wherein kukuha tayo ng inference natin for that population coming from our sample. Meaning to say, we don't have any population right now. So, this will be a 0 minus 0. Okay? So, next, for our denominator, let's have the square root of this number. N sub 1, what is our n sub 1? That is 15. So, 15 minus 1 multiplied to s sub 1. Then, we will go into square that. So, s sub 1, that is 700. So, 700 square plus, we have here n sub 2, which is 9. We're done with 15. So, 9 minus 1 multiplied to the standard deviation of the second population, which is 800. And we will going to square this one. Okay? So, all over n sub 1 plus n sub 2 minus 2, that is 22. So, diretso na natin, no? 22. So, multiplied to square root of 1 over n sub 1, which is 15, plus 1 over n sub 2, which is 9. Okay, so let's check our computation. So let's have our calculator. So 16,000. I will just delete this. So we have numerator and denominator. For the numerator, we have here 16,400 minus 15,700. Of course, minus 0. All over our denominator, we have two denominators here. Okay, so first, on the first square root, we have here, let's have fraction, okay? So, we have 15 minus 1. You can actually direct it on your calculator, guys. 15 minus 1, then 700, then let's have the square. Where's the square here? Here. And plus 9 minus 1 multiplied to 800 and then square. Okay? So, for the denominator, that is, let's direct na 22 because that is the degrees of freedom. Okay? So, multiplied to the another square root. Let's have our fraction. 1 over 15 plus, let's change the item, plus we have here, oops, let's set it, plus another fraction. So let's write here 1 over 15 plus 1 over 9. So before having the equal sign, no, take note muna, baka meron tayong maling input. 16,400, 15,170. So ayun, meron tayong maling input. This is 15,170. Check nyo muna lagi before kayo mag-equal. Kasi may mga times na ganun. Tapos yung unang nakita nyo palang sagot is nandun sa choices. Hindi mali na. Akala mo tama kasi eksakto pero mali pa rin na input mo. No? So, ayan. 15,170 minus 0. So, check. 15 minus 1, 700 squared. Plus 9 minus 1, 800 squared. I hope you guys have your notes ngayon. Sinasabayan nyo sana ako mag-compute para mas magamay ninyo. So, 1 over 15 plus 1 over 9. Okay. Upon having our answer, no, ayun na siya, nandito na actually. 3.95 or let's have 3 decimal kung gusto niyo. Pwede naman. So, 3.953 since we use 3 decimals din naman sa T-critical value. So, now, ano nang gagawin natin is that since we have found that the T value is 3.953, sulat muna natin dito no, para may copy tayo. So, 3.953. The next thing is to have our decision rule. Now, for the decision rule, gaya ng dati, let's have here 0, standard normal distribution curve, and yung dalawa nating critical values. I hope naaalala nyo pa ang ating critical values. We have 2 dahil nga we use the equal and unequal sign for the hypothesis. Therefore, magiging dalawa ang critical value natin. Kabilaan sila. Two-tailed test kasi. Okay, so let's have here the shaded area. Okay. Ano yung value natin ng critical? 2.819. Positive and negative. So, assuming this is the positive 2.819 and the negative 2.819. Okay. Ano naman yung na-compute natin? Sabi natin, we have 3.953. And nasaan si 3.953? On the positive side. More likely, nandito yan. That is 3.953. And since sabi natin, this is a rejection region, and that is the region where our T computed actually falls, no? Nandoon siya sa loob nun. Therefore, our decision should be to reject the null hypothesis. So, reject ang null hypothesis. Since we reject our null hypothesis, let's go back to our hypothesis. Na-reject ito, therefore, tama ito. And since ito yung claim, therefore, tama yung kiniklaim ng researcher na ang private school teachers daw does not receive the same salary with the public school teachers. Magkaiba daw sila nung nare-receive na salary. Hence, because of that, as you can see sa ating statistical na computation, our conclusion will be Since we reject the null hypothesis, we can conclude that there is enough evidence to support the claim on the alternative hypothesis that the salaries paid to elementary teachers employed in private schools are different. No, magkaiba sila dahil nga ito yung claim, tama ito, and we use not equal sign. So, are different, no, with public school teachers. So, that's how our topic is basically computed. Napakadali lang, no? Again, hypothesis testing to population, testing the difference between two means. Small, independent samples. I hope some of you may have used this in your project presentation. And I'm looking forward, guys, for the mastery ng subject. Okay, so I hope you learned something from this presentation. And keep safe always. See you on our next discussion. Bye-bye.